Cute little jump. Is that the best it can do?
Our suspension system is so great, you could put an egg here, and it would stay there. See? Oh, go back there, go back there.
Hello guys, new video, new RC vehicle. This time a US military, an earlier piece, Hummer H1 Humvee. With this project, our aim was to create something that is super fun and affordable on low cost. We scanned this one. This variant is from the 80s. Correct me if I'm wrong. We left the tow missile launch system and the side mirrors, as you can see, are different. The mirrors we went with are from the 90s. We designed these because the originals are really just saying, break me. We really need to speed up video delivery for you guys, so this model assembly was done in a super rush. No painting, no blending at body part joints. Well, hence even the up gluing. Sorry about that. And we kinda focused more on the chassis. But all this doesn't mean you can build it perfectly, so let's see the body assembly. How do we get from this pile to this? Let's see. The goal here was to make the design supportless. We can save a lot of material. My brother strived to position all parts for the best possible orientation for 3D printing. Most of the body pieces were printed laid like this. Thanks to this position, the parts have better features. Most of all, there is no layer delamination. When printed so, layers are squeezed and very much less likely to come apart. In Hell's Kitchen. Let's build. We got to the body's frontal mounting part. It is the same mechanism as before, but there is a newly added feature. As you can see, there are two M3 nuts embedded. We're not gonna use them here though. It is for you guys. As you know, Infinity, our newest truck chassis, which is used here, is famous for its versatility, mostly regarding its customizability. We'd like to add to body mount bases the same idea. If you want, you can screw them to the body. Magnets used here did not change. D8x4s. Here we glued these two black parts to the edges in order to hold the sides of the body properly. There's a trick here we'd like to share with you. Putting baking soda on the super glue will enhance the bond between these two body parts multiple times. It's not really pretty, but who cares? It's only the inside no one sees. We're building the pickup version, but here's an alternative, the slanted back roof. This big piece was also designed to be supportless. The back roof is so big that it actually exceeded our print bed. Only at the end of the print we noticed that the corners weren't even there. So we updated the file and split this roof into 3 main pieces. The 2 sides to be printed standing, the middle laid. You'll need to glue them together. There are also 3 connector pieces and 2 nut cases here at the end. These are to firmly attach the roof to the body. You'll need to drill 2 holes here for the screws to go through and to be used. There's much room for you to be creative with the antenna. As you can see, we didn't really spend any time with it. Quickly finishing up this bodywork assembly, and we're good to go to the chassis.
The name is Infinity.
Based on the lessons we learned from the Destiny project, we designed the knuckle to address common recurring issues. Many of you reported. Moreover, we also experienced that the knuckle holders and the knuckle steering arm were extremely fragile and broke easily. To solve this, we split the knuckle into 4 separate parts. Now all parts are printed in optimal orientation. This ensures greater durability, and in case of breakage, you only need to replace the specific damaged part instead of the entire assembly. All 4 parts can be printed without support. The dual bearing setup helps provide better support for the axle. Additionally, the axle itself is printed horizontally, just like in the previous project, making it much stronger. We haven't had one break yet, but let us know if you experience any issues. Fracture of the rocking arm was relatively rare, but did also surface sometimes previously. To address this, Bro split the rocking arm into 2 pieces. Again, this update allows the middle section to be printed in a much better orientation, making it extremely strong. Also, this design is much bigger, 10mm thick and 12mm wide. If anything breaks here, let us know and we'll try to reinforce it, although the design doesn't seem to allow for much more strengthening via thickening. In any case, replacing it will be simple from here on in. The upper adjustable arm, the turnbuckle, can be freely adjusted on the Hummer using an M3x25, allowing you to set the wheel's camber. We're attaching this enforced rocking arm to the lower and the turnbuckle to the upper section of this thing. Front tower. For the sake of variety, these parts can also be printed without support. This tower has 3 pieces, so in case of any accidents, replacing parts here also super easy, though disturbance in the force is untypical at this section. And the main reason we made the sides boltable, if you want to install a different frontal shock absorber for your project, you'd only need to reprint the sides. Let's quickly install the so far assembled pieces. We're using here a hold-hole 80mm shock absorber, which is smaller in diameter, only D14 compared to the D17 diameter version we used at Destiny, but that should also fit. Could be used here. This specific absorber from eBay was designed for M2.5mm screws to hold the suspension in its place, as we are keen to use mainly M3 metric screws, so the bill of materials are consistent and simple. We had to design custom parts to make the suspension compatible with the idea. For the top, we adapt to the factory mounting head design and made a custom 4.8mm diameter ball joint, which is sufficient. While for the bottom, we're going with a D6mm ball joint, along with an also custom printed mounting head. D6, because if we had to design something for the M3 adaptability, why not go bigger and better, so it will be less prone to crack/break. The black spring retainer remains the original factory part. If you have a different absorber and you also need something custom, like a spring retainer or a ball head here, request it on our forum and Bro might just be merciful enough to design it for you. He always is. Setting the desired spring tension. You know, you can even play with the oil inside. Altogether, we're using 8 absorbers right now, but if you're on a low budget, you can try using 4. The design gives you options. Now comes the part of the chassis where you can set the wheelbase. As you can see, we are putting entry nuts everywhere so parts can join properly. The 2 side rails, which allow the rear section to slide, making the chassis length adjustable within a range from 256 to 370. Does your dream vehicle you'd like to build fall into this? The upcoming unit is the steering mechanism, which includes a servo with a rack and pinion system. This is the first time we use a pinion in the steering. The rack will be installed later along with the other steering components. This is a middle rod complementing the 2 side rails in the wheelbase setting business. Finishing up the steering. The rack will slide on this mount. Can't really show you guys, it is so well hidden, but hopefully these 2 angles are enough for you to see how it works.
Nous venons d'arriver à la section arrière.
I mean, we've just come to the rear section, the heart of infinity. These parts are providing rigidity to the chassis. As you could see previously, the front section frame parts are less dense in order to achieve the adjustable wheelbase design. This piece holds the rear suspension. Now come 3 massive elements which hold the chassis frame together. And this is the denser counterpiece of the middle sliding rod. Looks robust, right? Well, that was the point. Upcoming, the gearbox assembly. We're using the same bearings here, just like in the knuckle before. We're placing a little gear on the motor shaft. This is the middle gear. And now comes the biggest one, which will be bolted to the cardan shaft. We don't want this gearbox housing to fall apart, so we use lots of screws and nuts. We're using 2 screws to fix the motor, but we're not tightening them just yet. The central gear was needed to create some distance between the motor and the output shaft, so they can fit side by side and won't inhibit each other's functionality. Why not having the motor the other side and have a direct drive? Because this way we gain more space and Infinity is even more customizable in terms of wheelbase dimensions. Furthermore, some greater torque never hurts in off-road cars. The gearbox ratio is 1 to 3.5. Differential ratio is approximately 1 to 2.5. So the overall gear ratio of the drivetrain is around 1 to 9. It can be clearly seen that the gearbox housing itself also serves as a reinforcement for the chassis frame by making it more compact. This is the rear drivetrain. We're building it with a printed bevel gear, although the differential version is being designed in the shadows. The rear axle width right now is fixed but will be adjustable just as the front one. A single shaft is used onto which the spiral bevel gear is mounted, then the housing is assembled with the bearings and screwed together. Ball head is secured in the cup with a grub screw. We have already modified, thickened and reinforced the components of this universal joint in 3 iterations. As always, your feedback would help a lot in further advancement. Thanks to the groove, the shaft can easily adapt to the desired length while in motion. All 4 joints, upper and lower suspension links, have the same length and feature ball heads, identical to those used for the lower mounting of the shock absorbers. We use countersunk screws here. This is how the suspension links keep the rear shaft in its place. Same absorbers here, we use 4 of them at the back as well, but again, the design also lets you use half as many. Install them according to your needs. Mounting systems. This is the middle one. The MMS, which connects body and chassis in the middle, is one of 4 connecting points. Bear with me. Frontal mounting system, middle mounting, rear mounting holes, which we are not using now because the Hummer's body provides us with a superior system. We'll get there soon. Back to the MMS. This is the counterpart piece of the MMS, which should be glued to the body. This is how we adjust the system's height to the body. Frontal mounting assembly. Unlike in previous projects, this design has been divided into 2 separate parts. The division is making it more resistant thanks to the improved printing orientation. As you can see, the MMS can slide along the middle rod, allowing you to position to its optimal location for body securing. The time has come to join the 2 chassis halves. Here you can witness the simplicity of adjusting the desired length. Infinite wheelbases with infinity, and soon tracks as well. Fixing the frontal body mount, motor controller and receiver bracket, installing the battery holder. We're using cheap Velcro and double-sided tape to fix the motor controller and the receiver. We're working on a solution to only use printed stuff for all shapes and sizes that need to be fixed to the chassis. So keeping the purchasing list simple. My brother divided the rim into 3 parts so it can be printed without support. Previously, it was a single piece and the amount of support required for printing was almost as much as the material used printing the model itself. That was sick. The 3 parts need to be glued together with a super glue. The tire is from eBay and its dimensions are the following. Infinity is almost ready. Now we just need to apply Hummer accessories. This Hummer chassis front is not set and it's adjustable, so it can be matched to any body height setting. For lights, we use the Tamiya 12 LED system again. Not all the LEDs are used right now, only 8 head, tail, and 4 turn lights. Body and chassis joining time, so finishing up the body kit part of the frontal mount with the usual magnets. As the Hummer body at the back is giving us this 4th option of body and chassis fixing, we have the luxury of leaving the middle mount completely. So we're only using the frontal mount and this rear Hummer chassis to body fix.